Hi all, welcome to the new video of Computer Fundamentals and HTML. In this video, we are going to discuss sum of products and product of sum, then minterms and maxterm in boolean algebra. Now we are going to discuss sum of product, that is SOP, sum of products. It is a method of simplifying boolean expressions of logical gates. Sum of product, that is SOP, derived from the symbolic representation of the OR and function. That is, OR means logical OR, that is addition, and logical AND, that is multiplication. OR can be represented by plus symbol, and can be represented by dot symbol, that is for multiplication. See this function, that is f of a comma b comma c equal to abc or a complement b c complement. Here we note that a and b and c, that is product, and also a complement and b complement and c complement, that is also product. Now we are adding a and b and c and a complement and b and c, that is called sum of abc and a complement bc complement, that is called product of sum. We know that abc is product, a complement bc complement is product, then add these two products, then it is called sum of product, that is SOP. Now we are going to discuss product of sum, that is POS. When two or more sum terms are multiplied by a boolean expression, it is called product of sum. Some terms are defined by using OR operation, that is OR means plus, and product of term is represented by AND, that is dot operator for multiplication. See this diagram, f of a comma b comma c is equal to a bracket of a complement or b, then close the bracket, and that is product bracket of b or c complement. We note that a complement or b is sum of terms and b or c complement is sum of term. These two sum of term we we multiply, that is called product of sum, that is POS. I hope you understand. In the sum of product term, we adding product of terms, and the product of sum we multiplying sum of term. I hope you understand. Now we are going to discuss canonical form. In SOP or POS form, that is sum of product or product of sum form, all individual terms do not involve all literals. For example, AB or a complement BC is the first product term, do not contain literal C. We understand that in the first product term, that is AB, we don't have C. If each term in SOP or POS contain all literals, then the expression is known as standard or canonical form. I hope you understand. If each term in SOP or POS contain all literals, then the expression is known as standard or canonical form. Now, canonical form. Each individual term in the POS form is called maxterm. Each individual term in the SOP form are called minterm. That is product of sum canonical form. Each individual term in the POS form is called maxterm. Each individual term in the SOP, that is sum of product form, is called minterm. In minterm, we look for the functions where the output result is 1, while in maxterm we look for functions where the output result is 0. We perform sum of minterm, also known as sum of products SOP, and we perform product of maxterm, also known as product of sum, that is POS. Now we are going to convert sum of product to standard SOP form. We need to go through the 4 steps. First, step 1, find the missing literal in each product term if any. Then second step, and each product term having missing literals with terms formed by or in the literal and its complement. Then step 3, expense the term by applying distributive law and reorder the literals. Step 4, reduce the repeated product terms because A or A is equal to A by theorem. Now we have an example for this. You can understand by this problem. We have function f of a comma b comma c is equal to ab plus bc plus ac. Ab plus bc plus ac, plus you can read as or ab or bc or ac. Step 1, it is called sum of products. Now find the missing literals in each product. We can understand that in AB C is missing, in BC A is missing, in AC B is missing, and after this step the product term with missing literal or its complement. Now we add AB and C or C complement, or BC and A or A complement, or AC and B or B complement. How we do this? We know that in the first term we have AB, so we add C or C complement. In the second we have A missing, so A or A complement. In the third term we have B missing, so B or B complement. Missing literals and their complements. Now in the third step, expands the term and reorder the literals. Now AB, that is C or C bar plus BC, A or A bar plus AC, B or BR. Expand and reorder. Now we have this term ABC, that is ABC, then ABC bar by theorem. We have discussed a lot of theorem under Boolean algebra. We can understand AB and C or C bar is equal to ABC or ABC bar. Like that we do all these things. Now we will get ABC or ABC bar, ABC or A bar C, BC, then or ABC or AB bar C. Expand the bracket. Now for omit repeated product terms that we have, we can note that ABC is repeated, omit it. Now the result is ABC, ABC bar, then A bar BC and A bar BBC. We have ABC repeated in 2 times, we omit this ABC. Now this is the converted form of SOP to standard SOP form. Now we are going to convert POS to standard POS form. Similarly, the same method we can use here. Step 1, find the missing literal in each sum term if any. Step 2, or each sum term having missing literals with terms formed by and in the literal and it is its complement. Now step 3, expands the term by applying distributive law and reorder the literals. Now step 4, reduce the repeated product terms because A or A is equal to A. Now here we have the example. This is product of sum, that is POS. Now A or B and B or C and A or C, we have this, we have the problem. First we do what is the missing literal in A or B. In A or B, C is missing, in B or C A is missing, A or C B is missing. Now step 2, or the sum term with missing literal its complement. Now we add A or B or C and C bar, then B or C, or A and A bar, then A or C, or B and B are missing B bar, that is B bar or B complement. Missing literals are and their complements as earlier in the SOP. Now we have step 3, expands the term and reorder the literals. We have A or B or C and C complement, B or C, A and A complement, A or C, B and B complement. Then expand and reorder. We have A or B or C and A or B or C bar, then A or B or C, A complement, or B or C, then A or B or C, then A or B complement or C. Now omit repeated sum terms. We have A or B or C repeated. Now this is the standard form, that is A or B or C, A or B or C complement, A complement B or C, A or B complement or C. This is the standard POS form. Now we need to understand two terms, minterms and maxterms. Minterms are AND terms with every variable present in either true or complemented form, given that each binary variable may appear normal. Example, x or complemented x complement. There are 2 raised to n m. Example, two variables x and y produce 2 by 2, that is 4 combinations, that is both norm xy, xy complement, x complement y, x complement y complement. We have 4 combinations. Thus there are 4 minterms of 2 variables. This is minterm. Now maxterm in the case of OR. Maxterms are OR terms with every variable in true or complemented form, given that each binary variable may appeal normal. For example, x or complemented form of x, that is x complement. There are 2 raised to n maxterms for n variables. Example, two variables x and y produce 2 into 2, that is 4 combinations. That is, we have the result x or y complement, x complement or y, then x complement or y complement. This is the max terms. Now we have the following chart for 1 to 7 binary numbers, 3-bit numbers. I hope you understand. Thank you.